So the following is going to be a sort of bonus video on how to simplify radicals. The first thing you need to remember about simplifying radicals is the perfect squares. So what do I mean by perfect squares? This should be a review from Algebra 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 13 squared is 169, 14 squared is 196, and we'll stop at 15 squared, which is 225. So those are things that you should be familiar with in terms of perfect squares. So maybe a few of you are confused even on what simplifying radicals is. So an example of simplifying radicals is I might have a number like the square root of 50. There's a way I can simplify that, and hopefully this little presentation will help you out. It all starts with the perfect squares though. So let's take a look at this. I'm going to give you 4 examples to hopefully show you how to do this. The first one is just the square root of 64. Well, we talked about perfect squares. The square root of 64 is a perfect square. We make our factor tree. 8 times 8 is 64. So the square root of 64 is 8. Let's go on to the next one. The square root of 28 is one where we can't just put in the square root of 28. If I put in the square root of 64 on my calculator, I'll get a perfect number, or a whole number, not a perfect number. But the square root of 28 is going to give me a number that will never stop. So what do? I have to see if any perfect squares go into 28. And if we're good with our factoring, we should know that 4 times 7 is 28. So what I can do is the square root of 4 times 7. The square root of 4 times the square root of 7. The square root of 4 is a perfect square, which is 2, and we put the square root of 7. That's how you would kind of do factoring by hand. It's not that complicated in most situations. A lot of you really struggle with your times tables. So here's a little method that I developed to kind of help you along. If I go to y equals on the calculator, which is in the top left, and all I'm going to do under y equals is put in the number 28 that's under the square root. So it's going to be 28, and I'm going to divide it by x squared. So square is the button kind of close to the 7 above log. And then all I'm going to do is second, and then I'm going to hit graph. So the reason why I have these key presses here is those are the actual buttons that I'm pressing. What I'm looking for now is a whole number in y1. So you see I have 28, I have 7, and I'll never have another whole number. If I keep scrolling down, I see that these numbers are less than 1, and they're just going to keep getting smaller. So the number that's furthest down that's a whole number is 7. So what it's going to be is 2 and 7. Well, if I go back to what I had before, notice that I had a 2 and a 7. This is going to work every single time. So 2 times the square root of 7. Let's go over a couple more examples, and hopefully you'll get the idea of this. Let's take a look at the square root of 180. We need to think of what perfect squares go into 180. So 180 is not as easy as 27. You should be able to see that 18 and 10 go into 180. And then you can kind of work from here. 5 and 2 are the factors of 10, and these are prime. So you might remember before, you circled those whenever you first learned how to factor. 18 can go to 6 and 3. 3 is prime. And lastly, 6 can go to 3 and 2. So if I break this up, it's going to be the square root. Let's put it in order. 2 times 2 times 3 times 3 times 5. Those are all my prime numbers. This is slightly different than what we did before, where we just pulled out a 4 from 28. But here we have pairs, right? This is the same as the square root of 2 squared times the square root of 3 squared times the square root of 5. And you should remember from Algebra 1, the square root of 2 squared, or the square root of 4, is just 2 times the square root of 3 squared, or the square root of 9, which is just 3, times the square root of 5. Last thing we do is we take the numbers on the outside. 2 times 3 is 6, and we're left with the square root of 5. So that's the way we do it by hand. Let's try that method that you might have thought was a little bit tedious with the calculator now. So again, the steps were, I went to y equals, and I put the number that was underneath the square root in first, so it's 180. So it's going to be 180 divided by x squared. And again, I go to second graph, and it brings up a table. I'm going to go as far down in y1 until I have the last whole number. So if you look in y1, 5 is the one that's furthest down. So I have 6 and 5. So it should just be 6 square root of 5. Again, whenever I go back to what I did before, I see I get the exact same answer. So you have a number of options to simplify radicals. It's not going to be an absolutely essential skill that you have down in geometry, although it's definitely going to help. But in Algebra 2, knowing how to do this will help you greatly. 448 is one that's pretty difficult to factor by hand. You'll probably need an assistance of a calculator anyways. So just to conclude here, let me show you that same calculator trick one more time. It's just going to be 448 divided by x squared. And I go to second graph again. I have to go as far down as I can. I see a 7. Will there be anything else better than a 7? The answer is no, because 7's a prime number. So I went down way too far. So whenever I go up to 7, I see that it was an 8 next to it. So this is going to be equal to 8 square root of 7. So just to verify that that was the correct answer, the square root of 448 and 8 times the square root of 7 are the exact same thing. I hope this video was helpful. If you have any questions about how to factor, how to simplify radicals, I should say, always feel free to ask me.